In order to write the equation of a line, we're going to need some point on the line and the slope. Sometimes the slope of the line is given, and sometimes the slope of the line will need to be calculated. Once we have a point and the slope, we're going to plug those values into the point-slope formula, which is y minus y1 is equal to m times x minus x1. If we don't do anything else to that equation, then our line would be in what we call point-slope form. But if we take the equation and solve it for y, we end up with our equation being in what we call slope-intercept form. When we're solved for y, we can see the value of the slope and the value of the y-intercept. And slope-intercept form is the form that we prefer when we're trying to graph a line. If we continue to work with the linear equation, getting the x and the y terms together on one side, we end up with our linear equation in what we call general form, and again, that's going to have the x term and the y term together on one side with the constant on the other side. Let's look at an example. We're asked to find the equation of a line, and we're given two ordered pairs that are on the line, and we want to express our answer in general form. In order to write the equation of the line, we need two things. We need any point, and we also need the slope of the line. So let's select one of these points to be the point that we're going to use. Any point will do, but since we weren't given the slope, this is going to need to be calculated. In order to calculate the slope between 2 points, we're going to use the slope formula, which is y2 minus y1 divided by x2 minus x1. Back up here in our ordered pairs, let's label one of these as the first point and the other as the second, so that when we're calculating our slope, we can stay organized. So as we have it labeled, y2 is negative 2. From the formula, we're going to subtract y1, which is positive 2. And now we divide by x2, which is positive 5. And then we subtract x1, which is negative 1. So we're subtracting a negative 1 here. This gives us a negative 4 in the top and 5 plus 1, which is 6 in the bottom. So the slope between these 2 points reduces down to being the value negative 2/3. And now we have what we need to continue by using the point slope formula. Let's recall the point slope formula is y minus y1 is equal to m times x minus x1, where x1 and y1 come from the point that we selected. So we have y minus, the y-coordinate of our point is 2, so we're subtracting 2 here, is equal to the slope that we calculated, which is negative 2/3, times x minus the x-coordinate of our point, which is negative 1. Now, anytime we are subtracting a negative quantity, we always want to change that to being plus. So let's make just that one adjustment. And if we don't do anything else, we would consider this to be the equation of the line in point-slope form. But remember, the directions asked us to write the equation in general form, so we need to continue working with this until we get it in the form of ax plus by is equal to c. Let's start by distributing the negative 2/3 into the parentheses here and dropping the parentheses on the left-hand side since they're no longer necessary. Distributing in negative 2/3, we get negative 2/3 x minus 2/3. Let's get our constant terms together on the right-hand side, so we're going to add 2 to both sides. The 2's cancel on the left, and we have y equals negative 2/3 x. In order to combine these two constant terms, we're going to need a common denominator. Notice that 2 is the same thing as 6/3, so when we say negative 2/3 plus 6/3, that's going to give us positive 4/3. Now let's pause for a moment and just make note of the fact that if we were to stop here, the equation of our line is in slope-intercept form. But again, we want general form, so we need to continue working with the equation. The only thing that we need to do now is to add 2/3 x to both sides so that our x term and y term are together on one side of the equation. Now what we have is 2/3 x plus y, and on the right-hand side, the only thing that remains is 4/3. And so we say now this is the equation of our line in general form. Some textbooks require integer coefficients for general form, so if that's the definition from your text, you could multiply both sides by 3/1 here. 3/1 times our first term, the 3's cancel out and we're left with just 2x. 3/1 times the second term, we have 3 times y, which is 3y. And 3/1 times the constant over here on the other side, the 3's cancel again and we're just going to have 4. So this would be the equation in general form, where all the coefficients are integers.